Okay, so today I'm going to try to make one of these ATARI controllers. And the reason why I need to make one is this is for driving, and hopefully this will be a paddle controller. And the difference, if you listen, let me put this next to the mic. I don't know if you can hear that, but there's clicking, and what that is a rotary encoder, which it's kind of like a potentiometer where it turns a rotation motion into a signal that a computer can understand, or a microcontroller, any of that. However, the way this sends the signal that it's being rotated is far different from an analog signal. This is more of a digital signal where it sends a pulse out as you rotate. That's the clicking you hear, is a couple switches inside clicking back and forth. However, this uses a potentiometer, and so it sweeps and changes the resistance as you turn the knob. The only flaw that I had when printing this, and the only part I have to reprint, is this knob. It goes on and off too easy, and if you keep rotating, you can feel it catching, but it rotates past its limit, and you don't want that because this will just pop off and you're going to lose this. So I'm going to reprint that a little smaller so it's a tighter fit. I already dry fit everything on here just to make sure everything fit pretty good, and it did. And I tried mimicking the controller as best I could without wasting a bunch of time getting it perfect. So I have, instead of a nice square block, I have some curves and rounded corners, while still making it where it's very easy to 3D print, because I don't want to waste all my time with failed prints. This was the first go, and it's good enough. Now, unfortunately, I couldn't find a schematic online that shows how to hook this thing up. Well, I found how it hooks up. However, I can't read this, and I couldn't find anything that tells me what value these potentiometers are. And when you're looking at this at the same time, it's kind of hooked up like a rheostat, where you don't have a voltage divider here. I assume the voltage divider is actually in the ATARI, but this is just acting as a resistor, and I believe this is 5 volts, pin 7. Pin 7's 5 volts, and then pin 5 is B paddle, and let's see, pin 8, that's probably, ground, and then pin 4 is joystick right. So I think what I'm going to do is wire it up for the left controller, because that's how most games play, is through the left controller port. So I'm just going to wire that up, and I'm not going to wire it up for both because I'm not sure how the ATARI is wired up on the inside. It could actually split this up between the left and right port, but it could actually have both ports wired together in such a way where it, if I wired them paired together like this, if it's a 2-player game, you wouldn't be able to play it because one controller will control both ports. But then again, it all depends. So I'm going to try just wiring up one side and see how it goes. And yeah, I'm just going to follow this schematic. You just have a push button, a potentiometer, and I'm going to wire it up in a way where I can just swap these out real quick to see what the proper value is. I'm going to start with a higher potentiometer and work my way down. So I'm probably going to fast forward me soldering up the connector and all that. Before I do that, it's important to note that these numbers are actually on the ports. Let me see if I can zoom in here. I don't know if you can see, but there's little tiny numbers corresponding to each pin. And that's very handy because when it's hard to look down at it and go, okay, Does it mean this pin on this side or this pin on this side? Because of the orientation, it's hard to know the orientation if they don't label it. So you can be looking down like this and wonder, okay, is this pin 1 or is that pin 1? But in reality, okay, so if you're looking down at the port, that's pin 1. So this is facing inward. But if you flip it around, that is pin 1. So it's important to look at that, and it's nice that most of these have them labeled. So I'm going to fast forward now, and hopefully you see it when it's all done. Okay, so let me talk about this for a second. Now, the way I'm wiring this, I have this little shielding that goes over this yellow wire, and the wire I'm using is actually for an analog security camera. So you have power, and then you have ground, video, and audio. And the video is shielded. Now, when you look at the schematic here, it has this right here is positive 5 volts, and then number 5 is going to be the other end of this potentiometer. Now, if I wanted to be proper to the color codes, I'd make this shielding ground and this red wire here positive. Now, the reason why I'm not doing that is they're all the same gauge wire. However, this shielding goes on this yellow wire, and if this, it'll get a better signal if this one right here is shielded with this potentiometer, because it's highly susceptible to radio interference the way it's wired up. It's essentially, if there's any radio signal that goes through this wire will go directly into the analog to digital encoder in the ATARI. So I'm going to try to minimize that by having this shielded wire shielding this signal wire for the potentiometer. It's not really good the way the color coding worked out. However, I think it'll work better, especially because this gauge wire is pretty thin and the cord's pretty long. So it's not proper as far as the labeling goes, but I think it'll be a better product by the time it's done. Anyway, now I'm going to fast forward again as I put this connector together because it's kind of a pain in the butt. Okay, so I got this thing wired up, and I put these little jumper wires on here That way I can put them in a breadboard and then just plug different potentiometers in and give the game a shot to see if that's the appropriate potentiometer for the game. I'm probably just going to force it in the one that I already have in here just to see if this one is already the correct potentiometer. I kind of doubt it because I just picked a random one. And while I was soldering this, I did notice that this red wire was a little thicker gauged than the rest, which if things give me problems, I might change the order of the wires around, but I think it'll be okay. So I'm going to go try it and see how everything goes. If it goes well, then I'm just going to solder in the new potentiometer and call it a day. Okay, so after some testing, I found out that the best potentiometer for the controller was a 500 kilo ohm potentiometer. The other ones either didn't register or the 1 mega ohm potentiometer registered, but it had way too fine, it was too jumpy, so there was too much play in it. So anyway, I'm just going to swap that out, and then after I swap it out, I'm going to address another issue that I had, which was the plug. I'm thinking, well, I'll explain after. So I'm going to fast forward and I'll give you a heads up when I'm done. This is pretty much done. I verified that it does work, and I'm pretty positive it's wired up in such a way where it, where these wires are actually bridged, and when you switch the ports, it knows which controller based on which port you're using on the console. However, the issue that I came across was when I'm using this port, which these are really cheap, but at the same time they're really cheap. So there's a lot of play in them. So as you push down, let me put it together so I can show you a little better. So it's together, but you can tell this has quite a lot of play in it. And what that'll do is, as you're plugging it into the port, the ATARI controller doesn't have this big bulky plastic housing. So when you try to plug them in, you can see it just doesn't have the length when it's pushing down on there. So there's a couple ways around that, and I can try wedging something under here to keep it from pushing as far back, and I can try shaving off a little bit of this plastic, and those probably will work. However, I don't want a probably will work. I want this to work every single time I use it, and as you can see, it's, even if it's optimized, you still don't really have too much room to play with. So what I think I'm going to end up doing is either getting some tapered screws and just making some sort of housing that slides on there, and then just simply screwing it in like that, and then if it's a tapered screw, it should be relatively flush, which will maximize what I can get out of it. Either that, or I can bend these little tabs inward and then make something that kind of clips into that, which, you know, that would probably work pretty well. But I don't know what I'm going to do. I don't know what I'm going to do for that. I might look and see if I have any tapered screws. If I do, it'll be easier to print something that just kind of slides in and holds it. But, you know, you only have what you have, and we'll see. Okay, so I just finished 3D printing this replacement part for this. So that should fit something like that. It's not perfect. I think I need to recalibrate my printer, but it should do just fine. Yeah, nice and snug. So now this, it'd be a lot easier rather than unsoldering these smaller connections to just undo this, tie a knot here, and then thread this back through, the knot being the strain relief. So I'm going to go ahead and do that, and I'll probably just fast forward that as well. Another problem you might have is the polarity of your potentiometer might be messed up. And the only way to fix that is if you just unsolder this connector right here and just put it on the other side, and that'll flip the polarity of the potentiometer and make it where it's going the right direction for the paddle. So anywho, we got the connector on here, and this is pretty much as flush as it can be. I have some brass tapered screws. They don't have to be brass, but that's the only tapered screws that I had. Have a nice strain relief on the inside of this. It's a little bulky, but that just makes it easier to hold on to. And yeah, so I just need to put it back together, and it should be good to go. So I think I'm going to reprint this knob and only make it about 0.5% smaller, because when you're working with things that are that small, even 1% might be too much. What I usually like to do is, if I really think the calibration of my printer's off, I need to spend a good day to calibrate it. But what I like to do is I print it, and then I measure what I actually got, and then I measure what I should have gotten, and I just make a ratio between the two and change the percentage of the print. And I only do that if I'm in a bit of a time crunch and I can't calibrate the printer, or if it's I'm only going to be making one of these, so you know, why would I go in, change the sketch, update it if I'm only going to print it once? I might keep a note of that, and if I upload the code, if anybody wants this thing, I can get a GitHub or something and put a detailed schematic and the STL file for this in there. And if that is the case, I'll make sure to have everything the correct size. So anywho, there we go. This thing, it works. I just need to print a better knob. So I have this nice, it's about I'd say it's about a 14-foot cord, so you don't have to sit next to the machine. The longer the cord, the better, in my opinion. And this is a nice sturdy plug. I can't see that wearing out. And yeah, so there you have it. This thing should work. Now let's go test it. Alright, so let's see if the new strain relief works. Looks like it works. Alright, looks like it's gonna work. So it works.
Well, hello.